Hello guys, in this video I would like to explain about the evaluation of the model, that what is mean by evaluation of the model. And before this we have done multiple videos about the data science process, and this is a playlist in this channel which contains 4 to 5 videos before this video, which is related to the data science process. And you can see in this figure we are trying to explain each part in the data science process. Before this, I have done a video on training the data science process, train the model in the data science process. And this video is about the evaluation of the model, that what is mean by evaluation and why we need to do this. The link to the previous videos is given in the description of this video. So if you want to know what is their data science process, and if you want to know about each steps, you need to see to watch these videos. So let's dive into the data science process, that what is mean by dive into the data science process, and particularly to evaluate the model. That is the topic of today video. Okay, we have done all the process until here. I mean, starting from here, a problem statement and objectives, data collection, data processing, that's mean cleaning, transformation, and other steps. Select ML model, that's means if you are working with the machine learning model, then ML model, and if you are working with the deep learning model, or generative model, or foundation model, or whatever quantum machine learning model, and so on. But this is I mean that we are just talking generally here, not about only machine learning model. It can be statistical model as well. So let's see what are the steps. I have done this in the data science, in the training the model, but let's see, we need to split the data into 3 parts, in fact 2 parts, but then we can divide the second part into the 2 parts. So this means training set, and then validation sets, and then the testing set as well. So we will talk about the testing set in the next video. You can see that validation set used for hyperparameter tuning and model selection. This is optional. So you can see that normally the people do this, train the model and then test the model and then they deploy the model. Actually, this is optional, but let's see. You can choose Python code, and to split the data into 2 parts. So you can use this command, so that you can use these commands, then this function, then so xtrain temp y temp is equal to train test split. This is a function from this that can use divide the data into these two categories. So this means that train underscore set underscore split xy test size is 0.4. That's mean it is 40% for the test and 60% for the training. And this is some randomization 42%. We have talked about this earlier in some videos about Python when we were doing some process, some videos in the early videos. But then we need to divide this data. This mean x temp and y temp. The trained data is okay, it is fixed now 60% for training of the model, but this y temp and x temp, we need to divide this into x evaluation or validation, and x test, and y validation and y test. So you need to do this again, the same command you need to use, and then x temp y temp mean you need to divide this x temp y temp into 2 parts. Size is 50, so 50%, and randomization is there, so you need to divide this into 50% again. So now we have 3 data sets: x train, y train, that is 60%, and then x validation, y validation, that is 50% of the test of the temp data, remember, which is 40% of the total data. And you have x test and y test, that is also 50% of the temp data from here, which is 40% of the total. Evaluate the model. Use appropriate valuation matrix based on the problem type, because that's very important. You should choose the appropriate selection, because maybe your problem is classification, maybe your problem is regression, or maybe your problem is about regionalization or zoning or dividing, cluster analysis. So you need to choose the appropriate valuation matrix. For classification, you can use accuracy, precision, recall, F1 score, and ROC AUC, and confusion matrix. You need to see all these terms, because I don't want to explain this, each in the single video. However, I can have separate videos on each of them, maybe in the future. So you can just look at the channel, and maybe you can watch this type of videos on these topics in the future. Uh, Now for regression, you can use mean absolute error, mean square error, and R square. And for clustering, you can use Silhouette score and adjusted R and index. So you can use you should know this about these things. You can search, and you can know about these things. So you can that's to show these things here. The purpose is to tell you that you can choose appropriate selection for model evaluation. Appropriate evaluation metrics. You can use Python code, and from this library, print accuracy and then accuracy underscore score. This is the function. This will calculate accuracy score from Y test and Y predict. So if you are testing the data, we will have a separate video on this, but you can calculate. This is just an example. Maybe you can see in this not here. This is just an example that you can use this function in this way. So this will calculate Y test and Y pred for the same duration, and you can get the accuracy. I have print classification report, and okay, this is classification report as well. So this command you can use, this function you can use from Python, and you can use for this data. So you can have the classification report as well. So this is something, this thing can help in the analysis. Okay, validate generalization. So now this was something about to evaluate the model, and validation is to generalize the validation to ensure the model generalizes well to unseen data. So I'm using evaluate and validation. Some you can use, you can evaluate, but this is validation. Also you can use. So generalization, this means to ensure the model generalizes well to unseen data. So you can use, for cross validation, something like this technique. So cross validation mean that you can you can generalize the model, in fact. So again, you can use in Python, you can use score cross underscore well underscore cross score model xy cv is equal to 5. So you can use this function. You can use cross validation for this the model which you have used. Then you can print score, and you can print score mean as well. So you can see that what is the score and what is the mean of the score. So you can use these techniques as well. And if you want to use, if it is necessary, you can use techniques like bootstrapping. You can use that as well for this purpose, for validate generalization. Check for overfitting and underfitting. You should know that what is meant by overfitting and what is meant by underfitting. I have talked about this already in data cleaning and data cleaning process. Of the data science process. The series of these of these videos, I have done this already. But if you don't know, you just go and watch the video of data cleaning of this series. Compare training and testing performance. You can do this by comparing the training and testing performance. Plot learning curves to visualize model performance on training and validation sets. Yeah, you can do like these techniques. You can see that what is mean by overfitting, what is mean by underfitting, and how we can tackle this problem. This is also given in that video, so you can go to that video and watch. check forward fitting and under fitting. So this is now on Python. You can see like this is an example. You can see train error, mean square error, y train, model predict train. So this means that y train is, you can say, training data, and model predict x train. So you can predict from x train, and you can see, you can say train error, test error. You can see by mean square error, y test again, like this y train. Now we are calculating test error. So y test and model predict x test. Of course, the same thing we are doing, but this is for test and this is for train. So we are calculating the error between the actual data for training and model predicted data for the same duration, and this is for y test actual data and model predict for x test the same duration. Now print train error and print test error. So this is the same thing which we have talked here. You can compare these error, the performance. So you can now have print train error, print test error, and you can see. So if you know the concept of overfitting and underfitting, then you can draw some conclusion here. Performance error analysis. Examine the misclassification or large residual to identify pattern or data issue. Visualize error, confusion matrix, residual plots. So you can do, you can do this misclassification or large residual to identify patterns or data issues. You can do this by visualize errors like confusion matrix, residual plot, and check specific areas of high error or misprediction. So you can do like this. If there is a dual and there is some high values, some lower values, you can see there are some problems. You can see that. This is now in Python. You can do like this. Seam confusion matrix, y test, y pred, and print confusion matrix. Yeah, okay, seem like this. So you can see. I think this already. You can do this in Python, and you can see the confusion matrix to see. Uh, I don't want to explain confusion matrix here, but I would like to have a separate video on confusion matrix because that's very important, and maybe some people don't know about this. So this is all about that. What is mean by training, evaluate, or validation of the model in the data science process. In the next video, we will have test the model. So this was an optional topic. I mean, in the data science process. So next will be test the model and then deploy the model. Can be the last option, because after deployment you have some data, you will have generated data, and then that's depend on the objective of your study, the analysis. So I will talk about this a little bit, but that's depend on your objective. So I think this is enough for today, and thank you very much, and see you in the next video. Ciao.